In this video, we'll look at a quick recap on inference. Okay, so each of these settings state which specific inference procedure you should use. For example, a two-sample z-test for a difference in proportions. Provide reasoning. You do not need to carry out any procedures. You simply want to know, can we identify our situations? Okay. So in the first one, is there a relationship between attendance at religious services and alcohol consumption? A random sample of 1,000 adults was asked whether they regularly attend religious services and whether they drink alcohol daily. What would be the inference procedure to do here? Well, because it's just a random sample of 1,000 adults, we only have one sample. And we're asked about attending religious service and drinking alcohol, and it's about a relationship. So we're looking for a relationship of categorical data. What would that mean our only option is? Well, if you said that it was a chi-square test for independence, you've got a good concept, right? When we're looking for categorical data, we know it's going to be chi-squared. When it's only one sample, we know that it's going to be independence, or it's going to be goodness of fit. In this situation, we're looking to compare the relationship, which is like saying an association, which is trying to see independence. Okay. What about the next question? All right. Separate random samples. In this case, we have separate random samples of 75 college students, 75 high school students. We're asked how much time, on average, they spend watching television each week. We want to estimate the difference in the average amount of TV. So estimate the difference in the average amount of TV. What would be the inference procedure here? Well, in this situation, we have two samples, because it tells us separate random samples, and we're looking for a difference of averages. So there's only one possible solution when we have this situation. And the answer, of course, would be that we're looking at a two-sample t-test for mu1 minus mu2. Right? Two-sample because we're looking two samples, mu1 minus mu2 because we're looking for a difference of averages, and a t-test, we do not know sigma. Right? Don't know sigma. Okay? If we knew sigma, then this would change to be a z-test. All right? But very straightforward for what we're working for. Okay? Now, as a piece of random samples, and we were looking to compare categorical data, then we'd be looking at a chi-squared for homogeneity. We showed the types of students that we're looking at, and we had more than just a single sample. Right? So if it was two samples and it was categorical data, then it would be chi-squared for homogeneity. Right? But in this case, two-sample t-test for mu1 minus mu2, because we do not know sigma. If we did know sigma, that would change to a z-test. Right? Always remember to ask questions for clarification. This problem happened to come from the Practice of Statistics, section 11.2, number 58.